One interesting variant on piecewise functions occurs when we have what is essentially an ordinary function with one or two weird points. Here's an example of what I mean. Here we have a function that's equal to 2x minus 4 if x is not 2, and it's equal to 3 if x is 2. That means that at every point except the point where x equals 2, this is just like 2x minus 4. So if we want to take f of 3, well, 3 does not equal 2, so we take 2 times 3 minus 4 equals 2. If we want to take f of negative 1, well, negative 1 does not equal 2, so we have 2 times negative 1 minus 4 is negative 6. But if we take f of 2, well, 2 does equal 2. So we use the second rule, and we just get 3. What this looks like on a graph is an ordinary graph with a hole punched in it. To graph this, we'll start by just graphing the ordinary function 2x minus 4. So we'll just start with the graph of y equals 2x minus 4. This is a line. It's in slope-intercept form. So we'll use the slope and y-intercept. We know we want our y-axis to go down to 4. And we know that our most interesting x value is 2, so we're more interested in positive x values. Our axes might look something like this. And the slope-intercept form means that we can graph without any arithmetic. We just put our y-intercept at negative 4. And then slope 2 means right 2, up 1. And we just go ahead and draw that line. Now this is the graph of y equals 2x minus 4. To turn that into the graph of y equals f of x, our next step is to put an open dot on the graph where x equals 2. So that's the point on the line that we drew where x equals 2. We can think of this as punching a hole. And then at the point where x equals 2, this function is not that line, but rather 3. So we'll put a closed dot at x equals 2, f of x equals 3. And this is now the graph of y equals f of x. If we're feeling particularly meticulous in our drawing, we might go in and erase the part of the line that's inside the open circle, but we don't have to. What we mean is clear. I'm going to give you one of these to try, because it's pretty straightforward, but it's sometimes a little bit difficult to get our head around. F of x is negative 2/3 x plus 2 when x is not negative 3. F of x is negative 2 when x is negative 3. Pause the video and try this now. So our first step is to graph y is negative 2/3 x plus 2. So the normal part of the function. We're going to set up our axes. Our y-intercept is positive 2. Our slope is negative 2/3. We're going to want to be able to see a bunch of multiples of 3 on our x-axis. And the interesting point is negative 3. So our axes might look something like this. We'll put our y-intercept at 2. And then slope negative 2/3 means we go right 3, down 2. And then we draw that line. So this right now is the graph of y equals negative 2/3 x plus 2. Our next step is to punch a hole in the graph, so draw an open circle at the point on the graph where x equals negative 3. So here's x equals negative 3. I find that point on the line where x is negative 3, and I put an open circle there. And then finally, as our last step, we put in the point where x is negative 3. So when x is negative 3, the function tells us f of negative 3 is negative 2. So I put a point right there. Notice that this function passes the vertical line test. Right, if I draw the vertical line at negative 3, this point up here is not part of the graph. Only this point is actually part of the graph. So that's all there is to graphing one of these functions with a hole punched in it, with one special point. Just draw the graph as if there weren't a problem, then punch a hole in.